Hey everybody, welcome. This is Tom, and this is the first video in a series of videos on genetic algorithms. Now, in this series, I'm not going to teach you what a genetic algorithm is. I've linked to a few other videos below that go over kind of the theory and the motivation behind using them. Like, why would you want to use a genetic algorithm instead of something else? But in this video, what I am going to do is show you how to program one up in Python. So you're going to get an idea of kind of how everything works under the hood. But you should be familiar with the idea of selection and reproduction and mutation within a genetic algorithm before starting this tutorial. If you're not, you'll probably still be able to follow through okay, but I think you'll kind of miss out on some of the underlying theory. So go take a look at some of those other videos, and it only take you 5-10 minutes, and then come back and things will make a lot more sense. Now, we're going to solve a problem called the knapsack problem, and it's a pretty old problem. It's fairly well known. You don't need genetic algorithms in order to solve it, and the kind of toy model that we're going to be using definitely doesn't need it. I mean, you can solve it by just looking at it when we first do our example. But later in the tutorial, what we'll do is I'll show you some other situations where it helps you find really good solutions when the set is really big. And by set, I mean these boxes here. We're gonna have like thousands and thousands of them. Now, to give you an overview of the problem, the basic idea is you have some container, in this case a backpack here, which is 15 kilograms, or can hold 15 kilograms. And you have all these other objects that you can put into the backpack. You don't want to exceed 15 kilograms. You don't have to be exactly at 15 kilograms. But the goal is to get all of the most valuable things you can inside this backpack. So the contents of the backpack have the highest possible value. Now, in this example here, there's only 5 little boxes. So it's pretty easy to see which ones we should take. But in other examples, you could have thousands or 10,000 boxes, and you're put them in this backpack or this container and find the optimal combination. So as we go through, we're going to have the constraint. The constraint is the max amount of items we can put in, which is 15 kilograms. And then we're going to have the objective, which is to maximize the value. So I'm going to go back to code. We're going to start coding this up. I go ahead and create my main function here, and okay. So I'm not actually going to create a backpack to begin with. What I am going to do though is I'm going to list the weights. So these are the objects to put in the backpack. And I'm also going to have the costs of each of those items. And then I'm going to have the max weight for the backpack, which I'm going to put at 15. So I'm just going to use the same thing from Wikipedia. Now these weights, I'm going to list these as 5, 6, 2, 3, 7, 9. And the costs, I'm going to put at 1, 2, 6, 7, 3, 2. Now you can probably look at this and you can figure this problem out pretty quickly, and that's fine. The point of this is not to create something really difficult at the moment that we can't just solve just by looking at it. So later on though, as I said, I'll give you some much more complex examples, and we'll see how the same algorithm performs under those conditions. All right, now in genetic algorithms, we have some sort of strand of DNA or something that is going to be representative, in this case, of our backpacks or the objects in the backpack. So each one of these strands, each one of these chromosomes or whatever you want to call them, is going to be one backpack. And we're going to represent it like this. So the backpack representation is really just going to be our weight list. So it's going to be something like this with 6 items in it. And we're just going to use zeros and ones in order to represent that backpack. So this right here, if you took a look at this one, it means this backpack will have something with 6, 1, or 6, 2, and 9. So it's going to be 6 plus 2 plus 9. Okay, so that would be a backpack that actually weighs 17 kilograms, which is impossible. So that was one we would actually throw out. Now, if I had another one, let's say I make one that looks more like this. Let's surround so it's a little bit like this. So this is a representation for another backpack. In this case, the weight would be 5 plus 2, which is just going to give me 7 kilograms. And how much is the cost for everything in that backpack? Well, it's going to end up being, if we match it here, we've got the first one, which is 1, and this one, which is 6. So it's actually going to be $7. All right, so that's what our backpack representation will look like. And we're going to want to build a whole bunch of those. So I am going to make 2 extra variables just for the sake of readability. And one is going to be the strand length. And the strand length I'm just going to make equal to the length of my weights list. The other thing that I'm going to do is I'm going to create a variable for my population, and I'm going to call it my population size, and I'm going to say I'm going to have a population of 100 to begin with. All right, so I'm going to go ahead and delete these examples so I clear out some room there. And we're going to make our backpacks. So this is the initial backpacks. It's going to be equal to get initial population. And it's going to say strand length, and population size. Okay. So this initial list of backpacks it's just really going to be 100 6-digit list. So it's a 2D list that's going to have it's going to have 100 rows with 6 columns. So let's go ahead and make that. Actual population, strand length, and population size. Good. All right, and so this shouldn't be really too difficult to code up, but all we've got to do is the following. So we are going to say backpacks. And we're just going to say for I in range population size, and we're going to say backpack is equal to, and we're going to need some way to make random numbers. So I'm going to say from random import random int, and I'm going to use a list comprehension here. If you're not familiar with them, basically what this is saying. For I in, there we go. J in range of strand length. So basically what this is saying is you're going to run this loop, which is going to be 6 in our case for strand length, and it's going to make a random number, and just kind of boom, 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 6 random numbers, and you're done. And they're going to be either 0 or 1. All right, and then I'm going to head and add my backpack to the list of backpacks, and I'm going to return backpacks. Okay. So notice, I'm sorry, I'm not going to call them knapsacks. I'm just too used to calling these backpacks. So, all right. Let's go ahead and print this out and see what we've got. Okay. So if I run this, what's going to happen is here. So I've got this list, and each row in the list is one backpack that's being represented. So 1 means I'm going to take that particular weight, and the 0 means obviously I'm not taking it, or that particular item. So some of these backpacks, if you already look down here, you're going to notice that some of them, like this one here in particular, it's not really feasible, because this would be a weight of 5, 6, this is 3 and 7, and that's 21, which is already, it's way higher than our 15 max. So we're going to want to clear those out. And if you come down further, there's even going to be some where you only have one item in it. So obviously we haven't even got close to filling the backpack. It's nowhere near optimal. Now, that's the basic initial population, and that's where I'm going to stop this video. In the next video, what we're going to do is we're going to go through this initial population. We're going to clear out all of the possible backpacks that are overweight, and then we're going to look at which of these backpacks are actually the best, which one's getting us closest to having a full weight, highest cost, that type of thing. Okay, so next video we'll look at the selection process, and then we'll move on from there. All right, see you next video.